Hello, my dear friends. I'm Shubham from LearnoHub, the free learning platform where you can study physics, chemistry, maths, biology absolutely for free at learnohub.com. So then, let's start. So friends, as you all know, we are studying your ICSE Chemistry class 10th, chapter number 6, Electrolysis, and in this video we are going to cover the entire basics of the electrolysis so that you could understand the examples as well as the applications of electrolysis which you have to study, which are there in your syllabus for your ICSE examinations. And also, along with the basics, at the end of this video we are going to solve some questions as well from your ICSE exams so that you would get a hold of the questions as well, how questions are being asked based on the concepts which we are learning in this video. Okay, so without wasting much time, let's start and let's rock. So first of all, the first question, that why should we study electrolysis? So let me tell you very interesting application of electrolysis. Okay, you all know water is made up of hydrogen gas and oxygen gas, right? But have you ever wondered to just separate the water back into hydrogen and oxygen gases, right? But yes, you can do it, and with the help of electrolysis. And the same thing we are also going to study in this chapter, how we are going to separate water into hydrogen gas and oxygen gas, right? Isn't it so much interesting? So also along with it, there are some very basic day-to-day applications which you would have seen with your own eyes as well when you are going around, going to the school or somewhere else. You have seen such iron rods in the construction places, or you may have seen some iron articles, and you know iron is used a lot, okay, for construction purposes, and where it is not used, we know it's used a lot. So what's the most vulnerable thing about using the iron is it gets corroded, right? It rusts, and if you want to prevent this rust, okay, if you want to prevent this poor little iron, okay, to get corroded, from getting corroded, so here comes the electrolysis. We can use electrolysis to save our iron. How? We can plate that iron with tin, with zinc, or with even nickel. And how we are going to do this? By using electrolysis. So this also we are going to study in this chapter. And also you can see on the screen this copper wires. We have studied from the childhood, right, that copper wires are used for transmission of electricity, okay, in the cables and all those things. So do you know that this copper wires, okay, if they have a very slightest of impurity in them, okay, the transmission of electricity would be affected a lot. So what is ensured is these copper wires are made absolutely pure, okay, and for making it pure, again we take help of electrolysis. So there are so many such applications of electrolysis. So I am actually excited to teach you this topic. So I hope you would also be excited and you would be interested to study now, right? So then let's start. Okay, so now let's first start with the electrolysis itself. Let's understand what is actually electrolysis. So its definition is simple. It's simply a process, okay, of bringing chemical change, okay, in whom? In a compound, okay, and that compound is in molten state or it is in aqueous state, okay. So that compound can be in molten state or aqueous state, okay. And how we are bringing the chemical change in this compound, which is either in molten state or in aqueous state? By passing direct electric current through that compound, through it. Clear? So I would make you understand this electrolysis, okay, just by giving you a example, and along with that we will actually do electrolysis here, okay. You would do along with me so that you would understand what actually is electrolysis, okay. So what all things are needed, what we have to do is, first we have to take a non-conducting vessel. We all know what is non-conducting vessel. It does not conduct electricity, okay. So I'm taking a non-conducting vessel, okay, here I have taken. Then what I need to do is, in electrolysis I need to bring a chemical change in a compound which is in molten state or aqueous state. And how I need to bring that chemical change? By passing direct electric current through it. So first of all, I need a compound, okay. In order to bring the chemical change, okay, in a compound, I first of all need a compound. Now how that compound should be? That compound should okay, should allow this direct electric current to pass through it, okay. then only we can pass the electric current through it, right? If that compound is not allowing the current to pass through it, then the current cannot pass. So I need such a compound which actually allows the current to pass through it, which means which actually conducts the current, right? So I need a compound which conducts electricity either in molten state, or it may conduct electricity in its aqueous state. I don't have any problem, but it should just conduct electricity in either of these states, in either molten state or aqueous state. Now I can use my knowledge of the chemical bonding, the ionic compounds, covalent compounds, and all those things to figure out a compound. See, we have studied ionic compounds in their molten state or aqueous state. Okay, they conduct electricity, right? So I would just simply take an ionic compound, right? Now I have taken NaCl, very popular and very favorite compound, right? So what I did is I just took the solid NaCl, I melted it. So I took a molten NaCl here. Fine. Now this molten NaCl, okay, is allowing the direct electric current to pass through it. Okay, so this means that it is conducting electricity, and such compounds, okay, like NaCl, such compounds like NaCl which conduct electricity, okay, in their molten state, or they may conduct electricity in their aqueous state. Okay, such compounds are called as electrolytes. Clear? So here NaCl, okay, is our electrolyte. Clear? Let me write it. So this is the first most important thing you need to understand in electrolysis. So we are done with it right now. Now what I have to do? I have to pass electric current through this electrolyte. Correct? For that, what I would need? I would need a source of electricity. Now, talking about source of electricity in electrolysis, what you have to remember, very important thing, is we can use two currents, direct current and alternating current. DC means direct current, AC means alternating current. Okay, so I can either use direct current or alternating current, but electrolysis is all about bringing the chemical change, right, in a compound, and our alternating current does not bring any chemical change, but direct current brings chemical change, right? So that's why out of direct current and alternating current, we always use direct current. Clear? Because it brings the chemical change, and electrolysis is all about bringing a chemical change in a compound. Clear? So what I would need a direct current source. Okay, so I have taken this battery, simple. And now further we would see how we would pass the current, okay, in this electrolyte. Okay, so now we have to do something that this electric current, okay, should flow, or we have to pass this electric current through this electrolyte. So we need to do something. So what I can do is I would simply take two wires, okay, I would connect one wire to the positive terminal, another wire to the negative terminal, and then I would take two rods, okay, and what I would do is I would connect one rod with the wire which is connected to the positive terminal. So I can say that I have connected this rod to the positive terminal of the battery, and I would take again the another rod and I would connect with the wire to the negative terminal of the battery. So I can simply say that I have connected this rod to the negative terminal of the battery. Clear? And at the same time, I would make sure that both these rods are dipped in the electrolyte. Okay, just like the French fries in the sauce, same way. Now here these two rods, okay, are called as electrodes. Okay, electrodes. So see, electrolyte, electrodes. Okay, so everything starting from yes, that's it. So this was the second most important thing which you have to know in the electrolysis. Okay, electrodes. And here in this case I am using graphite electrodes. Okay, now when we are using electrodes, we need to make sure that we are using such an material, okay, as an electrode which is also a good conductor of electricity, right? Because the current should, we want that the current should pass through this electrolyte, and we are dipping this electrode just for the same reason, in order to pass the current through this electrolyte. Okay, if that electrode itself is not is a non-conductor of electricity, then the electrons would get stuck here itself, right? The electrons won't enter the electrodes at all. Okay, so you have to make sure that always we use the electrodes which are good conductor of electricity. The material, it is good conductor of electricity, then only we use it as electrodes. Okay, so what is electrode then? We have just now seen. Let's see its definition. Simple. So electrodes are simply graphite rods, just like we have used here in this case. Okay, or metal plates or wires. So don't worry, we are going to use this also, metal plates and wires also, in some other examples of electrolysis, okay, which we are going to study further in this chapter. So electrodes are simply metal plates or wires or graphite rods which are immersed in the electrolyte. Okay, and these electrodes which are immersed in the electrolyte, through them the current enters and leaves the electrolyte. Okay, so how current enters and leaves the electrolyte, okay, through electrodes, we would see it, okay, later on, once we understand what is actually electrolysis, how electrolysis is taking place. Very clear? We would definitely get back to it. Now, these electrodes, they have some names, okay, they should have some names, right? Both of them, they cannot be anonymous. So the electrode, we started to name them. The electrode which is connected to the positive terminal of the battery, okay, that electrode is called as anode. Okay, so what is anode then? If someone asks you, it's simply the electrode connected to the positive terminal of the battery. Clear? And then the electrode which we have connected to the negative terminal of the battery, we call it as cathode. Okay, now this anode, okay, it is a positive electrode, okay, and cathode, it is a negative electrode. Now how you would remember it? A simple trick. See, it is connected to the positive terminal, so from that positive electrode, it is connected to the negative terminal of the battery, from that negative electrode. Clear? Now you would again have a confusion that which electrode is connected to the positive, which electrode is connected to the negative. Don't worry, I am also having solution for that as well. It's very simple. See, you have to just remember in this way: anodes A, okay, and additions A. Okay, addition means plus, right? So A addition, A anode, this means anode is connected to the positive terminal. Clear? Then that's pretty understood that cathode would be connected to the negative terminal. Clear? Okay, so now enough with the setup. Now let's get into action. Okay, so we are now going to switch on the current. Okay, and what would happen when the current is turned on? Magic starts to happen, right? So actually, let's understand this process. When we turn on the current, from the negative terminal, electrons start to move. Okay, because we know that electrons always flow from the negative terminal of the battery to the positive terminal of the battery. So that's why they usually, as usual, see their behavior, they follow the same thing. They start moving from the negative terminal to the positive terminal. Okay, so first they are starting to move from the negative terminal. Now how you would remember this thing? See, electrons are negatively charged, so they would absolutely have affection towards the positive charge. So that's why they would move to the positively charged terminal. Clear? And from negatively charged terminal. So that's understood. If they're moving towards the positively charged terminal, so they are moving from negatively charged terminal. Clear? So same way it's happening here. Electrons are starting to move from the negative terminal. They move through this wire and they reach this electrode. Okay. And now the interesting thing starts to happen. See, this molten NaCl, we know ionic compounds in their molten state, they dissociate into its ions, right? So this NaCl also doesn't remain NaCl. It just becomes Na plus and Cl minus. Clear? Like this. So here entirely in this molten NaCl, what is present now? Na plus ions, Cl minus ions. Na plus ions, Cl minus ions are present. Okay, and they are separated, right? So they are now free to move. Okay. Now once the electron reaches this cathode, what is happening? This positively charged sodium ions would start thinking that, yeah, I'm having something negatively charged here, okay, that is negatively charged electron there. Okay, so I'm like feeling some attraction towards this negatively charged electron. So that's why what it would start to do? It would start to move towards this negatively charged electrode, which means cathode, because of this negatively charged electron. Okay, in this way. And in the same way, chloride ions would also think that this electrode, okay, it is positively charged electrode, okay, positive electrode. So I would also go towards the oppositely charged electrode. Okay, why should I sit quiet? So it also starts to move towards the positively charged electrode, which means anode. So what is happening when we turn the current on? The cations, that means Na plus ions, are moving towards cathode. Okay, see, cations are moving towards cathode, migrating towards cathode, and here the chloride ions, which means anions, are moving to the positively charged electrode, which means anode. So anions are moving towards anode. See here. Now how to remember this very quickly? If you want to skip this logic, okay, if you want to quickly remember in your exams and all those things, so I am telling you a simple trick. See, cathodes C, cations C, right? So cations C, cathode C, it is matching, so this means cation would move towards cathode. Anodes A and anions A are matching, so this means that anion would move towards anode. In electrolysis, you have to remember this thing. Clear with it? Now let's see. Yes, they now started to move towards the cathode, the cations. Now anions are starting to move towards the anode, but what they are now going to do? This Na plus ions, they would go towards the cathode, and then the cathode would say, come on here, I will give you an electron. So this cathode gives up an electron to our Na plus ion. Okay, and Na plus ion, oh, it becomes happy by accepting this electron, and it becomes Na, sodium atom, right? Now in this way, so many Na plus ions go there, okay, near the cathode. They accept the electrons which are given by the cathode, and they become sodium atoms. And the sodium atoms now then start depositing on this electrode, cathode. Clear what has happened? In the same way, now we know chloride ions are moving towards the anode. So what they do is they go towards the anode, they go in close to the anode, in vicinity to the anode, and this chloride ions say to anode that, anode, I am giving up an electron. Okay, so take it. Okay, here. So then after losing the electron by the chloride ion, what it would happen? What it would become? It would become chlorine atom. Very simple. Now in the same way, so many chloride ions go there, okay, and they lose their electrons, okay, and they become chlorine atoms. But now we know that chlorine doesn't exist as atom, it exists as a diatomic molecule, okay, chlorine molecule, Cl2. Okay, so what it would do, it would then combine with the other chlorine atoms. Okay, this chlorine atom, it knows that other chlorine atoms are also getting formed in the same way in which I am forming, right? So I would combine with some another chlorine atom, and what I would become? I would become a chlorine molecule. And this chlorine molecule is a gas, so it just gets evolved, liberated at anode. Okay, so what is happening at anode? Chlorine gas is liberating at anode. Clear? Okay, now we would write what actually is happening at anode. So we know chlorine molecule is getting formed. Okay, so I would just make here chlorine molecule. But for if I'm now making two chlorine, right here, chlorine molecule has two chlorine atoms, so I need two chloride ions then, right? Now I'm having two chloride ions, so they won't give me one electron. They have two negative charges, so they would give me two electrons. Clear? This is the reaction which is taking place at the anode. Understood? Now we have to remember one very much important thing. In electrolysis, what happens is, whenever, okay, the number of electrons which are gained by the anode, okay, are always equals to the number of electrons given by the cathode. This thing. Okay, so here anode has gained how much electrons? See, 2 electrons. So it is always equal to the number of electrons given by the cathode. So cathode would also give 2 electrons. Okay, so I'm just making here 2. If cathode is giving 2 electrons, then 2 sodium ions must be required to accept that 2 electrons, right? Because 1 sodium ion accepts 1 electron. See, 2 sodium ions. Now these 2 sodium ions are accepting these 2 electrons, and they are becoming 2 sodium atom. Clear? Okay, they would become 2 sodium atom. Now we would write the net reaction. Okay, so writing a net reaction is very, very simple. Okay, what you have to do is, you can simply just write the reactants. Okay, in both the cases, in both the reactions, just write the reactants. Okay, all together. 2 Na plus 2 electrons. And what is the reactant in the second reaction? 2 chloride ions. Okay, I have written all the reactants on one side, okay, of both the reactions. Clear? Now I would put an arrow and I would write all the products on the other side. Okay, so all the products, 2 sodium, right? Okay, 2 sodium chlorine molecule and 2 electrons. Now what I would do is, whatever I am seeing similar on both the sides of this reaction, I would just cancel it out. So 2 electrons and 2 electrons. This is the only same thing. See, there are 2 sodium ions, 2 chlorine ions, 2 chloride ions. Whether you are finding here 2 sodium ions, 2 chloride ions, no. So only the same thing matching was 2 electrons. So I just cancelled it out, and whatever is now remaining, that is the net reaction. Very simple. So again I would write it down. 2Na plus 2Cl minus gives 2Na plus Cl2. Now what I would do is, we know that this 2Na plus and 2Cl minus, where they are? Here in this molten NaCl. So I would just replace this 2Na plus and 2Cl minus by NaCl and 2NaCl, because 2Na plus and 2Cl minus would become 2NaCl, right? Would combine and become 2NaCl. So 2NaCl, I'm writing here L, molten NaCl we have taken, and it is giving us 2 sodium atoms. Okay, this is in solid state and chlorine gas. Okay, so no need to mention the states. For your understanding, I'm mentioning the states here. Okay, and chlorine gas, because it is evolving at the anode. Sodium atoms are solid, because solid, that's why they are getting deposited at the cathode. So this is actually what is happening in our electrolysis. Okay, just wait a minute. Let's keep this reaction here itself, because this reaction would help us understand the definition. But let's complete the process. See, electrons are being then lost at the anode, or electrons are being gained by the anode. Now these electrons again start to move and just go to the positive terminal. Okay, so the current is flowing. Okay, we come to know that yes, current is flowing. Now you would say, sir, how we would come to know, right? I cannot see electrons with my naked eyes, so how I would come to know? Okay, touching the wire is also not a good option, right? So what you would simply do is, you just place a bulb here. Okay, if the electrons are coming at anode, okay, they would move through this bulb and the bulb would glow, right? If they are not coming at anode, okay, through the cathode, then the bulb would not glow. But what you would see, that whenever you are placing these electrodes in this molten NaCl, the bulb would start to glow. Why? Because see, electrons from the cathode have somehow reached anode, and then from there they are flowing and again coming to the positive terminal. So they are completing the circuit. Okay, and yes, the current is flowing, so bulb will glow. If current is not flowing through this, the bulb won't glow. But we see that the bulb is glowing. This means that electrons are reaching somehow to the anode from cathode, and then they are moving again to the positive terminal. Understood? Now let's come back to this reaction. Okay, see what is happening. What we have done, we have actually brought electrolysis. Okay, we have actually carried out electrolysis. How? See, we brought a chemical change. Okay, in this process, we brought chemical change in a compound. Okay, which compound? NaCl. Okay, how I'm saying I have brought the chemical change? Because see, NaCl here, it is the part of this reaction. Okay, it is reacting somehow and giving some products to us, right? So it is reacting and giving us some products. That's why we are saying that NaCl is undergoing a chemical change, right? Because it is giving some products to us. So we have brought the chemical change in this compound, okay, which is in molten state here. In this case, if NaCl is in aqueous state, then also we can bring the chemical change in it, because here NaCl is like a multitasker, right? It in its molten state as well as it in its aqueous state can conduct electricity. Okay, but some compounds, not necessary, they may conduct electricity in both molten and aqueous state. What is actually important for us is, an electrolyte is simply a compound which may either conduct electricity in molten state or in aqueous state. In any of the state, if it is conducting electricity in molten or aqueous, that is an electrolyte. Okay, no need for the electrolyte to conduct the electricity in both the states. Clear? So here we have brought the chemical change in this compound NaCl, okay, in its molten state. How we have brought? By passing direct electric current through it, right? Here we have passed the direct electric current through it. How we come to know? Bulb is glowing, correct? So we have done electrolysis. Clear? Okay, now few more interesting things about electrolysis which we have carried out here now. Okay, let's take a look on it. So what is this? In external circuit, electron flow is from anode to cathode. See, this is the external circuit, right? This wire, battery and this thing. Okay, so in external circuit, see, the electron is flowing from anode, right? And it is moving to the cathode, right? Clear? Next is electron enters the electrolyte through cathode and leaves through anode. See here, electron is entering the electrolyte. Okay, see, from the negative terminal, electron is moving and coming to the cathode, and from cathode it is entering the electrolyte and it is leaving the electrolyte through anode. But you would say, sir, I cannot see electron flowing through this electrolyte. So how you are saying that electron is entering the electrolyte through cathode and leaving through anode? Electron is actually not entering, but yes, somehow in disguise this electron is getting transferred to the anode. Okay, the electron at cathode is getting transferred to the anode, and that's why we are saying that electron enters. Okay, we just say that electron enters through cathode and leaves through anode. Okay, we cannot actually see it is happening, but in disguise electron is getting transferred from the cathode and moving to the getting transferred from the cathode to anode. Okay, now how the electricity is getting conducted then, right? This is the question. I have just now told the electron is being transferred from cathode to anode in disguise. And how this is happening? See, we have seen that these Na plus ions are moving to the cathode. They are taking up these electrons. Okay, now we have seen it takes up 2 electrons, right? And chloride ions, 2 chloride ions at the same time, they also just go and donates 2 electrons. Okay, so 2 electrons from here are being transferred from cathode are being transferred to the anode, right? So who is transferring the electrons, right? Ions. Okay, here ions are doing something that the electrons are getting transferred, and what they are doing, they are simply just moving to the respective electrodes. So the ions are migrating towards the respective electrodes, and then the electricity is getting conducted. So conduction of electricity is due to the migration of ions to the respective electrodes. For ions to migrate, what is important? The ions should be free. If the ions are not free, then they would not migrate, then the electricity won't get conducted. That's why we have studied in ionic compounds. In solid state, conduction of electricity does not take place, because in solid state ions are not free. They are like very much strongly attracted towards each other by the strong electrostatic forces of attraction, right? So since they are not free, so they cannot migrate to the respective electrodes and they cannot conduct electricity. Clear? And the last thing, electrolytic cell. So this entire thing, okay, this entire thing is a device, okay, and this is an electrolytic cell. Now what is happening here, you can just figure out. Okay, overall what is happening, we are having some reactant, okay, or we are having some compound, some chemical compound, okay, chemical compound, just like NaCl. What we did, we passed electric current through it. So we used electrical energy, okay, and what happened, this chemical compound get converted into some product. Okay, the products are also chemical compounds itself. So these products are having some chemical energy. Okay, so what you can observe here is the electrical energy which we are using, it is getting converted into chemical energy, right? In this process, in this device, and such a device, okay, which converts electrical energy into chemical energy, okay, is called as electrolytic cell. Okay, so now the next concept in the basics is oxidation and reduction. We have to understand what is oxidation, what is reduction, but in terms of loss or gain of electrons. Okay, so yes, we would understand this thing. So oxidation in these terms is simply the process, okay, it is a process in which an atom or ion loses electron. Okay, it just donates its electron, gives up its electron. Okay, so let's see an example. So this is our atom, sodium atom. What it would do, it is losing its electron and it is becoming Na plus ion. See, it is losing its electron, right? And it is becoming Na plus ion. After losing one electron, sodium atom would become sodium ion. We all know, right? Same way, suppose I'm taking sulfide ion here. Okay, not atom, sulfide ion. So it is losing its 2 electrons. Okay, and it is becoming sulfur atom. See, after losing its 2 negative charge, it would become neutral sulfur atom. So in this process also it is losing the electron. So see here, in both the processes, see, this is an atom, this is an ion, both of them are losing the electrons. Okay, so both these processes would be oxidation. Okay, because oxidation is simply the process in which atom or ion loses electrons. Clear? Next is reduction. So reduction would be exactly opposite of the oxidation, the process in which atom or ion gains an electron, right? So let's take an example. Again, I'm taking copper 2+ ions. Okay, now these ions would gain these 2 electrons and they would become copper atom. Okay, after gaining 2 electrons, okay, these 2 positive charges would be gone and it would become neutral copper atom. Same way, suppose I'm taking an atom, sulfur. Okay, it is gaining 2 electrons. Okay, it is now neutral, it is gaining 2 electrons and it becomes sulfide anion. Okay, see, S2 minus, it is gaining 2 electrons, so 2 negative charges on sulfur. Clear? So see, in these processes, in both these processes, here an ion and here an atom. Okay, they are gaining electron, right? So atom or ion gains an electrons. Okay, so this process is called as reduction. Such a process is reduction. So both these processes are reduction. Clear? Now why we have studied this? Because we are actually going to apply this concept to our electrolysis. Okay, so let's see how we can apply this concept to electrolysis. Okay, so in our electrolysis, okay, we have seen at cathode, these 2 sodium ions are gaining the electrons and they are becoming 2 sodium atoms. So here ion is gaining an electron. Okay, so what this process would be? Reduction. Okay, and in this, at anode, you can see here this ion, okay, is losing the electron. Okay, so when in the process if the ion is losing the electron, this means what is happening? What process it is? Oxidation. Just now we have studied. Okay, so I know now your pain, sir. We are having some difficulty in just these 2 terms. In which process electron is gained, in which process electron is lost. I will tell you a trick. See, oxidations O and loss of electrons O, right? You just match this O, right? In loss there is O. This means that loss of electron means oxidation. So gain would be reduction. Clear? Now coming back to this, at cathode what is happening? Reduction is happening because electrons are gained, okay, in this process. At anode, gained by the ions, okay, in the process. At anode, oxidation is taking place. Why? Because ions are losing the electron. Clear? So you have to always remember in electrolysis, at cathode reduction would take place always, and at anode oxidation would take place always. And now such a process in which both reduction and oxidation takes place simultaneously. See here, reduction is also taking place, oxidation is also taking place. Reduction is taking place here at cathode, oxidation is taking place here at anode, and such processes in which both oxidation and reduction takes place simultaneously are called as redox process, or we can say as redox reaction. Okay, so that's why, see, at anode reduction is happening, at cathode oxidation is happening. So we are seeing that redox reaction is taking place, and that's why we say that in electrolysis or electrolysis is a redox reaction. Clear? This is a very important concept. And one last very important thing, see, at cathode reduction takes place always. That's why we call cathode as reducing electrode. Okay, and at anode oxidation takes place always. That's why we call anode as oxidizing electrode. Okay friends, so continuing the basics of electrolytes, basics of electrolysis. Okay, and in this what we are going to study next is we are going to study electrolytes in a little bit more detailed way. Okay, so what are electrolytes? We have already seen electrolytes are those compounds, okay, which conduct electricity in their molten states or in their aqueous states. Okay, so if a compound is conducting electricity either in molten state or if it is conducting electricity in its aqueous state, we call that compound as electrolyte. Okay, but there are some compounds which conduct electricity in both molten state as well as in aqueous state. So it's better for us, right? It's good. They are like multitasking compounds. Now let's see the examples. So first are acids. Now see here, HCl, sulfuric acid, nitric acid, carbonic acid, acetic acid. All these acids, okay, in their aqueous state, they behave as electrolytes. How? See, we have studied acids, okay, when we add in the water, in their aqueous state means we are adding these acids in water, okay. What happens when we add acids in water? They ionize, right? They ionize, which means the neutral molecules of acids splits up into the charged ions, correct? And we get, right, ions in the solution. For example, I can take HCl, okay? So HCl, when we add in acid, this neutral molecule just splits up into these two ions, H plus and Cl minus ions. And these H plus ions, okay, we know that in water, they cannot exist independently. That's why they combine with this water and they form H3O plus. Okay, so this H3O plus and this Cl minus. Okay, these two ions are present in this solution. Now see, these ions are free to move, and since they are free to move, we know what else is required for conduction of electricity. Free ions are required so that those ions would migrate to the respective electrodes and conduct electricity. So see, these are having free ions. The aqueous solution of HCl is having free ions. That's why we are saying that aqueous solution of HCl, okay, is an electrolyte. Clear? In the same way, all these acids as well. So we have already seen in the acid, bases and salts chapter the ionization of all these acids. Okay, how these acids get ionized, okay, and they form these ions, okay, in their aqueous solution. So all these acids also form ions in their aqueous solutions. Therefore, these also are the examples of electrolytes. Same way, all these alkalis, NaOH, KOH, NH4OH, calcium hydroxide, these also form ions, okay, in their both aqueous state and molten state. Okay, and how they form ions, we have also studied this thing as well. NaOH gets dissociated, right, into its ions, Na plus and OH minus ions. Same way, this KOH, NH4OH, calcium hydroxide, they would also get dissociated into its ions in aqueous state as well as in molten state. Clear? Now, aqueous state we have studied in the acids, bases and salt chapter. How you would say, what about the molten state, sir? See, in molten state, why they are getting dissociated? Because see, these all are ionic compounds. And we know ionic compounds in their molten state, they get dissociated into its ions. So that's why they also get dissociated into its ion. So in molten state as well, they have free ions. So they conduct electricity. So they are also electrolytes in their molten state as well. Clear? In aqueous state, I have just told you, they get dissociated into its ions, and since they have free ions in their aqueous state, so they are also electrolytes. Clear? They also conduct electricity, so they are electrolytes. Clear? Now salts, NaCl, I have told you both in their molten as well as aqueous state, it has free ions, so it also conducts electricity. So that's why our NaCl in molten as well as aqueous state is an electrolyte. Same way, lead bromide in its molten state has ions, it conducts electricity. That's why it is also electrolyte in its molten state. Copper sulfate in its aqueous state, ammonium carbonate in its aqueous state, lead acetate in its aqueous state. These compounds, okay, they also in their aqueous state have free ions. Okay, here copper ions, sulfate ions, ammonium ions, carbonate ions, lead ions, acetate ions, and these free ions conduct electricity. That's why these compounds in their aqueous state are also the examples of electrolytes. Clear with the examples? Now, based on their ability to get separated into its ions. Okay, so first of all, let me tell you, here we would say in case of acids as well, they are getting dissociated. Okay, we won't just differentiate between ionization and dissociation for studying the electrolytes. Okay, for electrolytes, we will just say acids also dissociate, just like the alkalis. Okay, for not making it more or not leading more confusion, we just simply use dissociation, a single term. We don't switch to ionization and dissociation continuously. Okay, so here in case of acids also we are using the term dissociation. So we would say acids also dissociate into its ions, alkalis also dissociate into its ions. But now we know they dissociate into its ions and they have free ions, right? Acids as well in their aqueous solution, alkalis as well in their aqueous and molten state. Okay, salts as well. Okay, some salts are having the ions in their molten as well as aqueous state. Some salts are having in their molten state. So what my point is, we would just say dissociation. We would just use dissociation term. Okay, we won't use ionization term further. So now all these electrolytes, we know they dissociate into its ions. Clear? But based on their ability to get dissociated into its ions, okay, they are divided into two types: strong electrolytes and weak electrolytes. Okay, so let's see one by one what are strong electrolytes and what are weak electrolytes. Okay, so what are strong electrolytes? These are the electrolytes which dissociate completely, okay, into its ions in their molten or aqueous state. So what does this mean? Complete dissociation. We have already seen this term when we were studying acids, bases and salts. But let me quickly tell you, okay. See, if I would add an electrolyte, okay, and if this electrolyte, okay, in its aqueous solution means I'm adding this electrolyte in water, okay, and after adding this electrolyte in water, this electrolyte is getting dissociated completely, which means all the molecules of electrolyte, okay, would get separated into its ions. Okay, clear? This is what is called a complete dissociation. So in this water, okay, I'm just rubbing this, in this aqueous solution of the electrolyte, you would only find ions. Okay, you won't find the electrolyte molecules, okay, the compound molecules, you won't find it. Why? Because all the molecules of these compounds have been splitted into the charged ions. Clear? In the same way, if you would melt such electrolytes, okay, so you would observe that in their molten states, okay, in the molten states of such electrolytes, strong electrolytes, you would only find ions, right? Positive and negatively charged ions. You won't find any molecule of that electrolyte in their molten state as well. So this is what is called as complete dissociation. There is no trace of molecule left, okay, in their aqueous solutions and in their molten states. They only have ions in their aqueous solution as well as in their molten states. See this point. Okay, in their aqueous solution as well as in their molten states, the strong electrolytes only have ions. So why they have ions, we have just now seen. Okay, what is complete dissociation? Now I hope you would have understood it clearly. Now these strong electrolytes, they allow large amount of electricity to flow through them. Clear? And the examples would be, now see, we have studied the examples of electrolytes which are acids, right? Because acids in their aqueous solutions were forming free ions, and these free ions were conducting electricity. So acids in their aqueous solution, okay, since they are having free ions, they were behaving as an electrolytes. So those acids we have studied which dissociate completely into its ions. Okay, what are those acids called as? Strong acids, right? We have studied this. So such strong acids in their aqueous solution, so this strong acid, see, HCl, H2SO4, HNO3, okay, hydrochloric acid, sulfuric acid, nitric acids, these strong acids in their aqueous solution, they dissociate completely. Okay, you won't find a trace of HCl, H2SO4 or HNO3 molecules in their aqueous solutions. Okay, you would only find ions, and ions, right? So that's why the strong acids in their aqueous solution, these strong acids, okay, HCl, H2SO4, HNO3 in their aqueous solutions are examples of strong electrolytes. Same way, strong alkalis, those alkalis which would dissociate completely, right, are called as strong alkalis. So like this NaOH, KOH, we know these are strong alkalis, examples of strong alkalis. So these also, they dissociate completely into its ions in their aqueous solutions as well as in their molten state. Okay, and since they dissociate completely into its ions in their aqueous solution and molten state, so therefore they are examples of strong electrolytes. Clear? And next is salts. NaCl. This NaCl also dissociates completely into its Na plus ions and Cl minus ions. You won't find a NaCl molecule or NaCl unit inside the molten NaCl or inside the aqueous NaCl. Okay, aqueous solution of NaCl. You would only find Na plus and Cl minus ions. Okay. That's why it is also an example of strong electrolyte. Same goes with lead bromide, molten in its molten state. It also only has lead ions and bromide ions. Okay, no lead bromide. So that's why this means that it is also getting dissociated completely into its ions. So this is also an example of strong electrolyte. And last one is copper sulfate. Okay, these copper sulfate also in its aqueous state dissociates completely into copper ions and sulfate ions. So you won't find any copper sulfate left behind. You would only find copper ions and sulfate ions in its aqueous solution. So that's why it is also an example of strong electrolyte, because it is getting dissociated completely into its aqueous solution. Clear? Moving to the weak electrolytes. So these are the electrolytes which dissociate partially, okay, or we can say dissociates incompletely into the ions in molten or aqueous state. Now I hope you would have figured out what is this partial dissociation. This means that when we would take the molten, okay, electrolyte, molten weak electrolyte, okay, we would find both molecules as well as ions, right? Why? Because the molecules of this weak electrolyte in their molten state, okay, they would not dissociate completely. Okay, they are dissociating partially. This means that some molecules would get dissociated into its ions and some molecules would remain as it is. So this is the meaning of partial dissociation. Same way, when we would add such weak electrolytes in water, so that we are making its aqueous solution, there also these electrolytes would say that no, I'm not going to dissociate completely. Okay, my some molecules would remain as molecules only. Okay, and my some molecules would undergo dissociation and they would produce some positive ions and negative ions. Okay, so that's why, see, in their aqueous solutions and in their molten state, you would find both molecules as well as ions. Clear? So this was the concept behind the weak electrolytes. Very important. So many questions are being asked repetitively based on this concept. Okay, you have to use this concept and answer the different types of questions. Clear? These weak electrolytes are having both ions and molecules in their aqueous solution as well as in their molten states. Means in their aqueous solutions or in their molten states. And strong electrolytes have only ions. We have studied only ions in their aqueous solutions or in their molten state. Clear? And same way, just like strong electrolytes allow large amount of electricity to flow through them, weak electrolytes allow small amount of electricity to flow through them. And the examples would be, in case of strong electrolytes, there were strong acids, strong alkalis were the examples. Okay, HCl, H2SO4, HNO3. Here there would be weak acids, H2CO3, CH3COH. In their aqueous solutions, they dissociate partially. That's why they are weak electrolytes. Same way, weak alkalis, ammonium hydroxide, calcium hydroxide, they in their aqueous solution as well as in their molten state dissociate partially. Okay, so they also are examples of weak electrolytes. Now, I hope you know what is partial dissociation. I have explained you very well. Okay, and these salts as well, ammonium carbonate, lead acetate, these salts also in their aqueous solutions, okay, they are also dissociating partially. That's why they are also weak electrolytes. Okay, these alkalis, NH4OH and calcium hydroxide, they dissociate partially both in their aqueous solutions as well as in their molten states as well. Okay, clear? Okay, so far we have seen lot about electrolytes, right? Now it's time to see what are non-electrolytes. So non-electrolytes are simply the opposites of electrolytes, right? Electrolytes are those compounds which would conduct electricity in molten state or in aqueous state. Okay, so if the compound is conducting electricity in aqueous state, then also it is an electrolyte. If it is conducting electricity in molten state, then also it is an electrolyte. But non-electrolytes would be the total ulta. These compounds would not conduct electricity in their molten states as well as in their aqueous states. In short, they do not conduct electricity. Clear? So compounds which do not conduct electricity in its molten state as well as in its aqueous state. Okay, or aqueous solutions. Now what are the examples? Very simple: kerosene, alcohol, sucrose, glucose, urea, okay, distilled water. These are the examples of non-electrolytes. Now see what is actually happening here. Why they are not able to conduct electricity? Because these non-electrolytes, okay, the examples of these non-electrolytes, they in their molten state or in their aqueous state do not have free ions. Okay, so if they are not having free ions, since they are not having free ions in their molten state or in their aqueous state, okay, that's why they are not able to conduct electricity. That's why they are non-electrolytes. Clear? So what would they have then? They would simply have molecules, right? In their molten state as well as in their aqueous state. So they have only molecules. They don't have any ions. Okay, that's the reason they are not able to conduct electricity, and that's why they are non-electrolytes. So they have only molecules in their aqueous solutions or in their molten state. Very clear? One more interesting thing I want to tell you, distilled water. Here you can see in the example. So it is an example of non-electrolytes. Now you would say, what is actually this distilled water? Distilled water simply means purified water. Okay, so not the purified water which you drink in your houses by installing that purification machines and all those things. This purified water is obtained by a process known as distillation. Okay, now no need to go into details of distillation. I will tell you just one simple thing. In this distilled water, okay, there would be no salts. Okay, this water is free from salts, simply. So what would happen? See, normal water, we know it has some salts, and these salts, okay, they dissociate into its ions, and therefore some free ions are present, and that's why it conducts electricity. Okay, but distilled water, since it does not have any salt, okay, so no chance of having ions in this distilled water. No ions, then electricity cannot be conducted. But now you would say, sir, you only tell na that this water gets dissociated, right, into its H plus and OH minus ions. Okay, right? Or I can say gets ionized, okay, in H plus and OH minus ions. Self-ionization of water we have seen in these two water molecules, okay, they undergo self-ionization, and this H plus which I have written, okay, this is actually H3O plus. So they form H3O plus and OH minus ions. So initially what I have written is water, okay, is getting converted into H plus and OH minus ions. Okay, so one of this water is getting converted into H plus and OH minus, and these H plus ions are getting stick to this water, and they are forming hydronium ions, and the rest remaining is hydroxide ions. Okay, so this we have seen. So water also gets ionized into its H plus and OH minus ions. Then how you are saying that it is not conducting electricity? Very interesting thing. See, this water which we know, okay, that it, yes, dissociates into H plus and OH minus ions, but that dissociation is to a very small extent. Okay, so much small that this H plus and OH minus ions are present in very low amounts, so that it is not possible for them to conduct electricity. It is not possible for them to migrate to the electrodes and conduct electricity, because they are in very less amounts. Clear? That's why our distilled water is an example of non-electrolyte. Okay, so moving on to the last topic of the basics, which is the metallic conductors and electrolytic conductors. Now we will see quickly the distinguish between metallic conductors and electrolytic conductors. We would just quickly distinguish them, okay, both of them. So first is, we know what are metallic conductors, like see copper wire or any metal wire, okay, which we use for transmission of electricity, or any metal itself, because we know metals conduct electricity. So metallic conductors means the conductor which is metal, simply. So I have taken copper wire as an example. Electrolytic conductors or electrolytes, now we have studied a lot about them. I know no need to tell about anything about them, right? So what first point of difference between them is the conducting particles. The particles which conduct electricity in metallic conductors, okay, we know in this wire the electricity is conducted by the flow of electrons, right? So the conducting particles are electrons here in metallic conductors. But in electrolytic conductors or in electrolytes, right, we know we have these electrodes, and the electricity is conducted by whom? We have studied. Electricity is conducted due to the migration of ions to the respective electrodes, right? So who are migrating? Ions are migrating. So that's why who are conducting the electricity? Ions, right? So conducting particles are ions. Clear? Then electrolytic conductors, okay, how electron flow is there? We have studied. When we attach a battery, okay, if you know this thing, it's well and good. So this is the positive terminal, this is the negative terminal, okay, and we are having this wire and we have attached this bulb, okay. So what would happen? The electrons would start flowing from the negative terminal, see this negative terminal, and then it would move to the positive terminal. Okay, this is the flow of electrons in the metallic conductors. How you would remember? See, very simple. Electrons are negatively charged, so they would always have affinity towards the positive charge. So that's why they would move towards the positive terminal. Clear? And since they are moving towards positive terminal, they are moving from negative terminal. It's absolutely very clear. Okay. So the flow of electron is from negative terminal to positive terminal of the battery. Clear? From negative terminal to positive terminal. Now, electrolytic conductors or electrolytes, how is the flow of ions then? We have studied ions, cations and anions conduct electricity, right? Here. So cations migrate towards cathode, anions migrate towards anode, right? So this is the movement of the conducting particles, okay? Or how they conduct the electricity. How cations migrate towards cathode and anions migrate towards anode. In this way, electricity is conducted, okay, by the migration of ions to the respective electrodes. Clear? Then metallic conductors are good conductors, okay, both in their solid as well as in their liquid states, okay. But electrolytic conductors, we have seen, they are good conductors in their molten state, fine. They are good conductors in their aqueous state, fine. But they are not good conductors in their solid state, okay. So why they are good conductors in liquid state or say molten state and aqueous state? Because simply in molten state they have free ions. In aqueous solutions also they have free ions, right? We have studied ionic compounds in their molten state, they get separated into its ions, okay. We know that electrolytes, okay, in their aqueous solutions we have studied, they also have free ions like acids. Clear? So since they are having free ions in their molten state as well as aqueous solutions, they conduct electricity. So that's why they are good conductors in molten state as well as aqueous solution, but they are not good conductors in their solid state, right? The ionic compounds in their solid state, they cannot conduct electricity. We have studied. Why? Because they, in their solid state, the ions are being strongly attracted by the electrostatic forces of attraction. Clear? So the ions are not free, so they cannot move, so they cannot migrate to the respective electrodes, so they cannot conduct electricity. Okay. Next is, no chemical change takes place when the conduction of electricity takes place through metallic conductors. No chemical change. But we have studied in electrolytic conductors or in electrolytes, when we pass the electric current, chemical change takes place, right? So that's it. Okay, so now let's see some questions. First is, choose the correct word which refers to the process of electrolysis from A to E. Okay, A, B, C, D, E, to match the description 1 to 4. Okay, so first description is conducts electricity in aqueous or molten state. Now we have studied so many times this thing. Okay, what is this? Which word would match it? Okay, oxidation, no. Cathode, no. Anode, no. An electrolyte, yes. An electrolyte is a compound which conducts electricity in aqueous or in molten state. Clear? So we got our answer D. Okay, an electrolyte. Okay, next is, loss of electron takes place at anode. So what happens at anode? We have seen this. Loss of electron. Okay, can you just correlate this thing? Loss of electron. O means oxidation. So if loss of electron is taking place, okay, in a process, this means that oxidation is taking place, and oxidation is taking place at anode. Yes, we know at anode oxidation takes place. So our answer would be, the right word would be here, oxidation, right? Among this, and oxidation, cathode, anode, and reduction. Okay, this one is done. So right one would be oxidation. Then a reducing electrode. So I have told you a link. The electrode at which reduction takes place, that is a reducing electrode. Clear? Electrode at which reduction takes place. Now, at which electron reduction takes place? Cathode. We have studied this. So if I have told you to remember that in electrolysis, at cathode reduction would takes place always. So reduction at which electrode takes place? At cathode. So cathode would be our reducing electrode. So see, B. Okay, done. A is also done. So this is B, cathode. Okay. Then electrode connected to the positive end or terminal of the battery. So just we have seen while we are studying the basics, the electrode connected to the positive terminal, right? So I have told you a trick because you would get confused at the end of the day. Now among this, you can just simply tell, see, only what is remaining, okay? Anode and reduction is remaining. So you would tell, yes, it's anode, the answer is anode. But we should know, right? The right way is not to just eliminate the things. Okay, here we can just also figure out by having the knowledge as well. Okay, we have the knowledge that the electrode, okay, which is connected to the positive terminal is an anode. And how to remember it? I have told you, anodes A, additions A, right? So addition means plus, anode A and additions A means plus. So anode is connected to the positive terminal. Clear? So the answer would be C, anode. Okay, moving to the next question. Now I have written the year in which this question is asked in your ICSE exams here. Okay, so you can refer it. So no need for me to tell again and again while reading the question. Now, what is the question? Differentiate between the following pairs. Okay, we have been given the pairs based on the information given in the brackets. Okay, so let's see the first pair. What information is given to us? Conducting particles. What is the pair? Conductor and electrolyte. So just now we have seen, right? Conductors are metallic conductors. Okay, conductor here means metallic conductor. Electrolyte means electrolytic conductors. So we have to differentiate between them just based on one point, which is conducting particles. So we have studied. You can just simply write conductors have conducting particles as electrons and electrolytes have conducting particles as ions. That's it. You just write in the complete sentence. Next is cations and anions. Okay, formation from an atom. So we have to differentiate these two based on this information. Formation from an atom. So we know cations. This is very basic question. This has been asked. Means this is from like your first chapter itself. We have just studied cations and anions, how they are formed in your first chapter itself. But I have just added here it because in the syllabus, okay, in your syllabus in electrolysis they have points cations and as well as anions. So I just added here this question. So how you would differentiate between cations and anions based on the formation from an atom? Simply how they are formed from an atom, you have to just write. So how cations are formed? Cations are formed, okay, by the loss of electron or electrons, okay, from an atom. And how anions are formed? Anions are formed by the gain of electron, right? Or electrons, okay, by an atom. Okay, moving on to the next question. Choose the correct answer from the options given below. An electrolyte which completely dissociates into ions. Okay, so what actually this electrolyte is? This electrolyte is a strong electrolyte, right? We know the electrolytes which completely dissociate into its ions are strong electrolytes. So out of these four, we have to just figure out which is a strong electrolyte, and that is our answer. So alcohol, no, it is a non-electrolyte. We have studied the examples. So no. Carbonic acid, H2CO3, it is a weak electrolyte. Okay, no. Sucrose, again non-electrolyte. Sodium hydroxide, NaOH, yes, it is a strong electrolyte. We have studied the example. NaOH, okay, it is a strong alkali. It dissociates completely into its molten state as well as in its aqueous state. Correct? Next is name the particles present in. Okay, so first strong electrolyte, second non-electrolyte, third weak electrolyte. Okay, so actually they are meaning us that name the particles present in the strong electrolytes, aqueous solution or in their molten state. In the non-electrolytes, okay, in their aqueous solution or in their molten states, or weak electrolytes in their aqueous solution or in their molten states. Okay, but they haven't just written it clearly. Okay, so we have to understand this thing. So what are the particles present in them? We have studied in case of strong electrolytes only ions, right? In case of non-electrolyte, only molecules. That's why they cannot conduct electricity, because there are no ions at all. Okay, so only molecules. And in case of weak electrolyte, both ions as well as molecules, right? Okay, so next is copy and complete the following table which refers to the conversion of ions to neutral particles. Now, conversion first is of chloride ion to chlorine molecule. Okay, so I have to write the ionic equation. So how would I write? Simply, we have to just use what they have given to us. Chloride ion to chlorine molecule. So here it would be chloride ion. Okay, and here it would be chlorine molecule. Okay, so now what I have to do is I have to write the ionic equation. Now how chloride ion is becoming chlorine molecule? See, first of all, to become a chlorine molecule, we know chlorine molecule means 2 chlorine atoms. Okay, so 2 chlorine atoms means here we need 2 chloride ions. Correct? First thing. Then how these 2 chloride ions would become 2 chlorine, how it would become chlorine molecule? These 2 chlorine atoms would combine and form chlorine molecule. But what is remaining? 2 negative charges are remaining. So these 2 negative charges are then lost as 2 electrons. Clear? This way you have to write the ionic equation. Very simple. Now, what is this actually? They are asking us. Is this process a oxidation or reduction? Okay, so we have to just see it carefully. The ions, okay, what they are doing? They are losing the electrons. Correct? So in a process when ion loses electron, loses, L-O-S-E-S, O means oxidation. So it is oxidation, simply. Okay, next is lead ion to lead. So lead 2, okay, ion. This means that we are having this Pb2 plus ion. Okay, this lead 2 ion means what it is forming? 2 lead. So it would form lead. Pb, just Pb. How it would form? See, this lead 2 plus ions is having 2 positive charges. So it is becoming neutral lead atom. For becoming neutral, it has to satisfy its 2 positive charges. How it would satisfy? Okay, it needs 2 negative charges, right? Or I can simply say lead is having 2 positive charges, which means that this lead atom is short of 2 electrons. So I am just giving it 2 electrons. So lead ion, 2 plus ion, is eating that 2 electrons, okay, and it is forming lead atom, right? Then no need to balance this thing, see, because it is already balanced. 1 lead, 1 lead. Clear? Now this is the ionic equation. Now what is happening? See, the ion is gaining the electron. So losing the electron is oxidation. That means gaining the electron means reduction. So simply reduction. This process is reduction. So see, this simple concept would gain you 4 marks in exams. Okay, so you need to be very much clear with the concept, then you would be able to solve very much different types of questions. Okay, now seeing the last question. Identify the substance underlined in the following case. So what is the substance underlined? Particles is underlined here. Now what is this case? The particles present in the liquid such as kerosene, that is a non-electrolyte. Okay, so if at all they would not have given us what is kerosene. Okay, it means actually it is a non-electrolyte. This thing, if at all they won't give us, then also we can find the answer, right? Because we know kerosene is a non-electrolyte, and we have studied non-electrolytes in their aqueous solutions or in their molten states, or we can say liquids. Molten state means liquids. So these non-electrolytes in their liquid state or in their aqueous state, okay, we can call liquid state as the molten state as well. Okay, so non-electrolytes in the liquid state or aqueous state, we know they have only molecules. So this kerosene in the liquid state, which is a non-electrolyte, it would also have only molecules. So what particles are present? Only molecules. So friends, with this we have reached the end of this video, and I hope you would have enjoyed learning with me. You would have understood all the concepts which we have learned so far. Okay, but please do let me know this thing in the comment section, and we would see the remaining concepts of this chapter in the next video. So till then, stay tuned, take care, bye bye, and have a great day.